Hello there. This video is for the last summary slide that we did not cover in class on Wednesday on function notation. I made this for students who maybe missed class for the Explore test or wanted to look at it for review. It's a good summary slide for function notation. So there's an equation in the upper left that says f of x is equal to negative 2x plus 4. And then we have this big table going on the right. So in my table I can see that I have an input column, which when I talk input, we all know that that's going to be my x. I have output in function notation, output numerical, ordered pair function notation, and ordered pair numerical. So I included all of these, like output function notation, output numerical, because I want you guys to understand that we only have one output, but there can be two ways to write it. So I can write the output in function notation or numerically, just like I can write my ordered pair in function notation, or I can write it numerically. They say the same thing, just two different ways to write it. So if I look at my input, is negative 8 for the first one. If I'm going to write my output in function notation, all I'm really asking for is what y would look like, but in function notation. So in that case, I would do f, back up for a second, I would do f of negative 8. That is my output in function notation. That's what y is. When I plug it in, I get that out. So now if I want to write it numerically, I actually go through, plug it in, get the number answer. So I would do f of negative 8 equals negative 2 times negative 8 plus 4. So following order of operations, I get f of negative 8 is equal to 20. Now that is my numerical answer. So really, those outputs are telling me the same thing. They still represent the output. But one's written in function notation, one's written numerically. So now if I do my ordered pair in function notation, my input is still negative 8. Now my output is f of negative 8. And then if I want to write my ordered pair numerically, it would become negative 8, 20. So just showing you that there's different ways to write the same thing. So now if you guys want to do a couple more, go ahead, keep watching. I'm going to go through a few more. So now I'm going to do if I did negative 5 for my input. So again, my output in function notation would be f of negative 5. I haven't actually done any calculations yet. Go through and plug it in to get my numerical output. So I have negative 2 times negative 5 plus 4. Negative 2 times negative 5 is 10. 10 plus 4 is 14. So that is my numerical output. Now my ordered pair is function notation. Well, my input is negative 5. Output is f of negative 5. And my output numerically, my input is still negative 5, but my output would be 14. So that's one more example. The other thing you might see if you look farther down the table, like, actually the next one we could do, I actually give you the output instead of the input. So now we know output is like y, so that must mean I have to solve for x. So to get anything done here, I'm going to have to solve for x first. So I am going to plug 10 in for f of x is equal to negative 2x plus 4. And now I'm going to solve for my x, which you guys know how to do, so subtract 4 from both sides. 6 is equal to negative 2x, divide out my negative 2, and I get x is negative 3. So now I actually know what x is. I know what my output is numerically. Now if I want to write my output in function notation, I can. I couldn't do that before until I knew what my input was. I can now write my ordered pair in function notation, so negative 3, f of negative 3. I can write my output numerically. Input is still negative 3. My output was 10. I encourage you to try a couple more of these on your own in the table. Like I said, it's just a good summary slide to help understand the different ways we can write outputs. So we can write it in function notation and we can write things numerically, just like we can with ordered pairs. When you guys are working on homework this weekend or on the review, make sure to email me with questions. Thank you.